Hello Amiga coders, this is Photon of ScoopX. We are making a scroller, aren't we? So let's continue. But first I got some questions by a guy named Chuck909. That would be the German spelling, probably inspired by Kraftwerk. And he asks, he tells me that he always knew org, the assembly directive, as origin. And that's correct. In tutorial number 7, where I talked about memory, I got into the org command, and indeed, I was wrong. It doesn't mean organize at all. It means origin. All this according to the author of the assembler, the guy who decides what the abbreviations stand for, Rune Gram Madsen. Of ASM1, and indeed it's more, I would guess it's more common interpreting org as origin than organize in other assemblers as well. Either way, it's an assembler directive from way back, present in most all assemblers up until Amiga and probably beyond. But it was, of course, necessary to, on CPUs that didn't have PC relative commands, or where it was very cumbersome to write PC relative code, to just say where to assemble the program to in memory. Of course, there are command line assemblers as well that may produce object files as output directly and will never assemble to memory. But I would say it's vital on anything, on any operating system, I would say, that don't have relocation functions such as Amiga DOS has. So he also asks about relocatable code. He asks if the org command is omitted, does the code get assembled as relocatable code in ASM1? Well, I would say there's no such thing as relocatable code. It's a misnomer. The code itself is not relocatable. You can write it as PC relative or relocatable as you want. You can use the PC register as the base address. You can load any of the address registers as a base address and only use only address offsets to that base address, and so on. There are all kinds of tricks to write code that you could just copy anywhere into the memory and it would run without a problem. The cause for the problem being that when the instructions are assembled, the assembler, if the instruction is not PC relative or relative period, then it knows, well, it's allocated a bit of memory, either on a fixed address or in the workspace, and as it assembles the program, it knows where the current instruction is, and so it can calculate these absolute offsets and put them into the instructions in memory. These absolute offsets, if you're not using relative code, are then written. If you write a binary file and you load it into memory at a different address and you run it, then of course any instruction that isn't relative, which has an absolute offset in it, will point to the wrong address and mayhem will ensue. Well, not always, but mostly. So that's about that. And the point in time when relocation or any such thing comes into play is when the operating system loads an object file. That is, you could say it's an executable file. It's not a binary file, but it's executable thanks to the operating system reading a header in this executable file, this object file. with telling the operating system in this header where the offending instructions are. Well, not offending, but the instructions that are non-relative. So I hope all is clear. So that the operating system reads this this header and corrects these absolute offsets in the code, and therefore it can load it to any available free memory and execute it. So inside the assembler, there's nothing special going on. Hopefully, the assembler will assemble your instructions as written. So if you're not using relative instructions, then your code will not be relative, and you will be able to see this. If we load the latest tutorial and we type an equal sign, we can see the amount of bytes spent on relocation data in this header, should we write the binary to an object file. So that's all there is to that. And I've spent too much time talking about this, but I wanted this correction. So it's origin, not organize, and there's no such thing as relocatable code. There's only relative code, and you can write it any which way. You can even read a pointer and add manually you can load a pointer to a data register, add an offset manually to that data register, and then put it in an address register, and then read from that address, and it will be relative code. I don't know anyone who would do that, but it might be necessary if you're running out of address registers, say. Okay, so here's where we were. We had made a plot char subroutine. This is our main loop. Waits for the raster, moves the raster bar, scrolls an area of the screen, and plots a char to a different position on the screen, specified by scroll Y at the moment. Scroll Y, because we can. So anyway, here's classic misspelling. What is the matter with me? So there we are. We'll load a base register for the custom chips, wait for the blitter, load up the blitter, and blit it. So that's how we plot a fixed character to a fixed position on the screen. And let's see how that looks first of all. We took the first character in the font and plotted it to the bottom left corner. So what happens if we put it in the scroll area? So we're going to change the scroll Y. I'm going to move that up, say 70 pixels. Just guessing now. Hang on. It's not using it, is it? Oops. Scroll Y. What the hell did I change? Better load it again. Scroll Y. There we go. That's better. And we can see that we scroll a bit too much, don't we? So I need to correct that and make it how high? I think it was 24. We can soon find that out. Maybe it was 20. We should only scroll as much as the chars are high, and they are 20 high. So scroll it. So we had the blitter height. I'm going to lower that to 20 and see if we're aligned vertically correctly. No, we should go. Well, that depends where we want the scroll, doesn't it? So, you know what? I'm going to put it down again to outside where we have our little init loop, which pokes the number patterns. see what that is. That's it, I think. Here's a tip for you. If you want to sort of make a multi-line comment, you could write something that reads well, such as this. This is an assembler directive. It's a conditional assembly. If this expression is true, then assemble this, else skip it. And NC stands for end conditional. Better not make a mistake. Better look it up in the manual, but I'm too lazy. End conditional, let's say. And I don't know why it's not called end if, but anyway. So that should leave our screen nice and cleared, and our scroll at bottom. And the screen width is 320, so we're gonna make a scroll X if we have it already or not. Nope. I don't know why I'm stressed. I guess I'm trying to get this. I guess I spent too much time talking about that origin thing. Okay, so 320 minus, and the characters were 32 wide. And you can make calculations in these assignments. So that should move the character. Oops. Well, we haven't used it yet. So we're gonna have a destination address. And that should be it. Yep. So it's the lower right corner, and we need to move the scrollable area down there, and then we might not be able to see what we're doing, so we're working blind here. But maybe I'll be able to do it anyway. So we did this, and we did this, and we're going to scroll some more now. I'm going to widen that to the full screen width, and we should have maybe this must be changed as well, because that's the modulo for it. So when you change the width of a bullet, you must also change the modulo. And we're going to put it at x0, right? And at y100. And let's just check that we don't need to modify any else of these constants. Now if we call this plot character routine every frame, as I think we do now, then of course after the scroll has scrolled a few pixels, or 1 pixel even, it will, depending on what we set the scroll value to here, I deem the scroll value to be 4 characters per, I'm sorry, 4 pixels per frame. So we're going to make that 4. See how that looks. Well, sort of. I don't know why I stopped that. Nothing should happen, because the scrolling takes place inside a fixed rectangle. On the other hand, if you're plotting bobs instead, and you find a bob moving outside of the screen, especially vertically, then you want to exit the demo before it overwrites the memory outside the screen. Or just add a check, but normally you make sure the coordinates are within the screen. So that seems to scroll 4 pixels per frame, but it does not seem to. Let's see what happens here. Actually, I think I'll just, well, to adjust this then, we need a counter, right? That counts counts down by 4 each frame, and when it's 0, we could count up as well. Could be more logical, so let's do that. And then we need to create a counter in memory, because we can't just declare a constant here, or an equate even, because the equates can change as the assembler assembles, and so that you can create an assembly loop that repeats a bunch of lines a bunch of times, and in that you can have an equate that increases or decreases or is multiplied or whatever. And the constants don't get changed at all by the assembler. They can only be declared once. So in order for it to change in real time, all the real-time variables must be declared in memory. They could be declared on the stack that we mentioned a few episodes ago, or the simplest way, and a way that allows you to name them, is to declare an address in memory as a counter, as we've done several times before. So let's find our data area. Well, there are some choices. You could, if you want to mix data with code, then it's very nice to have the variables by the routine that uses them. Of course, if you have shared, if several routines share a variable, then you would not want that, or you basically it's a matter of choice. We could declare a scroll counter and make that a word, and that would count up from 0 to 32, and when it hits 32 or higher, it would wrap around to 0. And that would do the trick. But if you want to keep it pure, then at some point you might want to put all the data in a separate section, a data section that could be in fast memory instead of chip memory, and stuff like that. So put it with the other variables, I say. And we don't seem to have very many variables so far. So there it is, and the scrolling should take place each frame, right? And the plot char should only be called sometimes. So the place to put the if command, if you will, that decides if you're going to plot a character or not, should be in the main loop, right? So we've used this command before. We could even point an address register to it. And I'm just gonna check if I'm still recording, because I'm worried about that. Yeah. All right. And let's have some more music. I like to strike a blow or make a small commercial for SceneSat Radio, hosted by a friend of mine, Jon Korhog, also known as Zephoid. And I think a show has just started tonight by Hazel. Hazel is hosting a show, I think, that started 2000 CET. So tune in and check it out. I'm gonna be careful not to press F10 to get a little bit. Okay, so we increase that and we can compare. You know what? Let's do it another way. We load that into a data register instead, increase it, and if it's larger than or equal to greater than or equal to 32, then it should wrap. So as long as it's lower than, it's okay. That's the signed version of the comparison. The unsigned version is lower than. So why not use that? And I'm lazy, so I'm just typing that. We could make it more legible like this. But of course, if we have any more counters in the main loop, you'd have to distinguish them somehow. And if it exceeds or equals 32, we just subtract one character's width from the counter. And whichever way we go there, it should be okay. And all we need to do is to store it. And here we can't use PC relative addressing, unfortunately, because the instruction set is not made that way. That's why I started by loading pointing an address register to it. There are several methods to remove this non-relative instruction. And make sure to, when you store the value back, don't put it inside the wrap code, because that will only get executed sometimes, since it's in a sort of an if statement here, a runtime if statement. However, you should plot a character when it wraps. So that means that the character should now, I'm going to write this to disk, and it should now scroll a bunch of characters. How about that? As you can see at the right edge, well, first of all, we have a problem with the top row there. Don't know if you can see it. Might suffice to add another line to it, or maybe just move the scroll rectangle up 1 pixel. And you don't need to worry about why that happens, because the reason why that happens is because you programmed it that way, and the computer always does what it's programmed to do. So I think we can also see that, well, either way, it's like blobbing out characters at the right edge, which is normal, because we've told it to replace anything on the right hand position, 320 minus 32. At that X position, it should replace everything within a 32 by 20 rectangle with the character of our choice. And the scroll routine is just taking whatever is inside the rectangle and shifting it to the left. So, how about we move that up a bit? BLTY, wasn't it? So, I don't know. I'm not questioning it. So it's okay, now I see it. So that's probably why you should use descending mode to... Well, of course this happens. It has nothing to do with ascending mode or descending mode, but everything to do with the fact that we are moving the rectangle. We are moving the source one word to the left. And therefore, data gets written to the right-hand edge. The right-hand edge of above the topmost line. The right-hand edge of the line above the rectangle that we're scrolling, if that makes sense. Because we just moved it up, 2 lines of gunk gets scrolled into that region. Do you want an explanation for that? Maybe. We have a bottom right corner. No, I might be wrong. Doesn't happen often, but sometimes does. Let's try that. No. So we've got a nice little bug here. So what's going on here? The bottom right corner is right there. We subtract 2, right. So that's it. We start at the bottom right word of the scroll rectangle, and we continue for what is it, 20 words width and 20 lines height, which when the blitter is finished puts the pointer at, no, it should decrement after, should still be okay. It was ages since I made a simple scroller. Plus, we're using my recommended descending mode, so I have nothing to blame this on. But let's have a look at that again. It's clear that as soon as there's any data in the scrolling rectangle, as soon as it hits the left edge, it starts leaking into the top line, and it keeps scrolling left. That's the clue. That means that the scroll rectangle is 1 pixel too high up. And probably if we change this to 101, let's check what it adds to make the blitter height -1. Well, that's certainly better. I mean, I don't see any ensuing problems with this. So the problem, I think, is that... No, that's correct. So, modify that around. Well, that's not... didn't help us much. ×2. What the hell? Right. Because the blitter width is in words, so that's nothing special about that. And the elite coders will sit and quietly snigger at me for having trouble writing a simple scroller. Well, you know, I've been sick for a while. No, for reals. I've had sleeping problems and a following stomach disorder. So I was just saying I've been away from the source for a while. So actually a good recommendation is to never stay away from the same source for too long, because you forget things and you forget how you implemented the scroller and blah blah blah. You know what? I think I'll do it like this. I will advance a few steps before I'd planned. That's not correct English, is it? I will skip ahead a few points. I was planning to do a bunch of things first. I was planning to do the indexing of the characters and writing a scroll text and seeing that happen before I address the problem of the blobbing out. We have a problem, namely that at the right edge, as you can see, it just replaces it. It should scroll smoothly in from outside, somewhere outside the screen, right? So the way to do that is to make the buffer wider than the display. And why not have a look at screen bitplane here? So what we want to do is check that we don't use anything special here, because we're also having the logo. So let's see how that fares. That should leave the logo undisturbed and the scroll text with the wrong modulo, which is to be expected. Here's our buffer, so we're not using these for any other parts of the screen, if you know what I mean. That was what I was checking for. And the music has stopped again because I'm being assailed by people calling me. Just as I'm recording this, have they no common sense? So anyway, check out Hazel's show anyway. This is part of it in the background. So that's it. So we need to correct the modulo. So we check out the copper. And this is a separate modulo for the logo. And down here is, I think I don't set the modulo, do I? Yes, I do. So what we should do is the modulo should be screen bit plane. We're gonna skip one bit plane, right? So the usual way to write this is to have the total width in bytes of a line on a screen. This is in interleaved bitmap mode, and subtract one visible display line. So presumably that would work. Now the offset is calculated differently because in our scroll routine we are using 320 still. We should scroll the entire screen, and this is becoming pointless now, isn't it? But actually we could save one word of the blid, but I don't want to bother with that now. We should, and that would still not work. We need to use the full width here. And the rest of the code should not change. And we should still get characters that appear abruptly onto the screen, because we haven't changed the, I should call these scroll y, plot y and plot x instead. So why not do that? Scroll y, plot y, global, scroll x, plot x, global. Actually, I think the connection is dropping on me here for the music. Could be the app. My app is called Online Radio, so perhaps you should go with another app if you're using Android. And of course we should change this. We might as well look for another. Whoops. That's the logo, so that's okay. That seems okay. So we have not changed our display width. It's still 320. What we've done is we've made the buffer wider. We've still aligned it to the top left corner of the lower screen buffer that you see on the screen, and therefore two words or 32 pixels, a strip of 32 pixels is outside the right edge of the screen, which is where we plot our character. Of course, I didn't want to do it the correct way first of all, because then it would have been less pedagogical, so that I could call plot char all I wanted, and you wouldn't see a character, and I would have to explain why you don't see it, because I'm plotting it outside the screen. I swear. So anyway, that's it. We've got a scroll text full of A's, and everything is working perfectly. So how about that? As you could see there, you would get junk at an address slightly higher in memory from where the scroll rectangles started in memory. And that is still there. That junk is still there, but it's hidden in the right-hand margin. So if you do this for a partial rectangle on the screen, you would need to clean that up somehow. So, okay. It's time to plot another character, I think. So we should change the source dynamically, right? I'm sorry, this one dynamically. Right now we just pointed to the font and take the first character in there. And the font had, I don't remember how many characters per line, but I think it was 10 characters per line, right? Something like that. And we would need to take that into consideration. We would have to look up the so-called ASCII or ANSI value of a character, which is a value from 0 to 255, or in more detail, all the text that you read on a computer is coded into bytes or words or long words, depending on the character set that you're using. And this char set is different from a character set that you draw in Deluxe Paint. It's a standard where, for example, in the ASCII and ANSI standards, a space character, a blank space, is the numeric value 32 or hex 20. A capital A is decimal 65. A capital B is 66, and so on. And you have various things like digits that start at code 48 and goes through to 57. That's the numbers 0 through 9, and you can Google ANSI table or ASCII table to get the actual numeric values. And we need to make a mapping for that and map that onto a grid of characters. That's all I'm saying. So, for example, if we add 4 to this, then we've moved 32 pixels to the right in the font picture, and we should be able to get a B instead, which we do. And I see there's a problem there. It does not seem to want to either plot or scroll the top left corner. Do you see that? So do we blit weight? Yes, we do. Do we blit weight before we scroll? Yes, we do. So it's not a fault in our code per se, it's a conceptual fault. There's something we're doing wrong, and we need to find out what's wrong with our axioms or decisions or something like that. So the way to test what it is to change our plot Y to move it above the scrolling rectangle area, and we get nothing because it's plotted outside the screen. And we just put it the left-hand edge instead, and it plots fine. So it's the scroll routine that is to blame. So probably some of you, the top students, have spotted my error, the error of my ways already. So we can put it back anyway, and should I worry about that or let the idea come to me about what's wrong with the scroll routine? What the hell? We do have a little bit complex calculations here. We could replace this with fixed code just for testing. That's one way of doing it. Check this. No. And this could simply be replaced by glitter height times screen bit length times 3 minus 2. Simplify that. And probably soon we'll find the error. Of course, then it became wrong. Why is that? What the hell? I've spotted the error already, but first let's find out what that is wrong. What's screen bit plane? And that's fine. This blitter height times screen bit planes times 3, that should point us to the word after the last word of the scrolling rectangle. So why doesn't it? Am I pointing the screen to somewhere else? No. We got a blit offset here. Which evaluates to 101 times that. Okay, so now it's becoming clearer and we can simplify it even more. We can correct this. I think this will fix it, but yeah. So now we are scrolling correctly, and we can just simplify this. 100 times that plus nothing, and it's looking much simpler already. And blitter skip is 0. Cleaning up somewhat. So anyway, that was quickly fixed. Sorry for that bug. Sometimes you make changes to code, and one of the changes you make goes unnoticed, and then when you're actually using the code that depends on it, you find out how wrong you were all this time. So we are scrolling correctly, and we know how to look up characters, don't we? We added 4 and we got the next character in the alphabet. So probably I'll need to look at the font picture to determine how this mapping should work, but what am I looking at this routine for? How about we did we have a font bit plane or something? You can set up various constants here to help you multiply things and calculate offsets and so on, but I'm gonna keep it simple. Let's say I add one line. Well, that won't do. 320 times the height of a character divided by 8 to get the byte offset. And that was obviously wrong. And so we do an ink bin of the font, and it's 284, so no wonder. So that makes it probably 288. This time I'm being assailed by people calling me, turning off my music. I understand the app has to turn off the music if the phone rings, but still. Oh yeah, octave bass. So anyway, I'm just checking the actual width, which is 288, and well, we can use 288 divided by 8 to get it. So that's the width of the picture that we're fetching fonts from, and it's still not correct because we're not skipping enough bit planes, we're just skipping one bit plane here. So 288 times 3 bit planes times 20 height divided by 8. That gives us the J character. Which number of the alphabet is that? I bet it's the 10th character. You can find that out by subtracting like this. No, it's 9 characters per line, of course. They are 32. That's why the font picture is less than 320 in width. So we got 9. That's an interesting number to multiply by. So, but basically we can create a row constant here, font row, and that gives us the same result, of course, and that's an offset to add for each line of characters in the font picture. And if you really want, I'm gonna skip that. We don't need that. We know the characters are 4 bytes wide because they are 32 pixels wide. So how do we do this? Well, let's start by writing a scroll text. That's always a good place to start. I am full of imagination for my variable names or label names. So whether you want to type in, we only have uppercase characters, right? So we should only type uppercase text. This might look a bit blocky, and there's no real reason for using uppercase characters anymore in fonts, but just for the retro feeling of it. So we have some alien characters in there as well, and we need some way of wrapping the scroll text, so why not make a label for that? We might also have an end token like that or something. It's up to you. I find that a wrapping pointer is more flexible in that you can have multi-byte special operation commands mixed in with the characters in the scroll text, so that you know that whenever the scroll pointer is higher than this address, then you'd better wrap it back to the start. Also, if you do it with a label and you need for some reason to swap out buffers or something, you can make a duplicate of the first line of text after this, and when you swap the buffers you won't get a glitch. So anyway, that's the scroll text. Now to plot the correct character. So we need also a scroll pointer, right? This is all very basic. Whoops. Scroll text. And what I did there, just to refer to this relative code and relocation again, this is a non-relative address. That means that when this long word is declared as data, it gets filled with the absolute address of where the scroll text starts. That means if the program is loaded into memory by some other means than the operating system, the pointer will be way wrong and you will get garbage in your scroll text. But I don't care right now because I'm counting on the operating system to take care of that for me. When we're finished with this demo, we only have what we're going to do is we're going to scroll the text, we're going to move the scroll text around, we're going to move the sprite around in a little more interesting fashion, and we'll replace this horrible smiley with something perhaps animated. I haven't made up my mind yet. And then we're going to make music, and then we're going to convert it, and then we're going to play the music, and when that's done, then the demo is done. And after that I could do a tutorial on how to optimize, how to make code PC relative, and all these things. For an initial tutorial on hardware programming, it's a bit overkill at this stage. So I just spent like 3 minutes talking about something that beginners shouldn't learn, didn't I? I'm sorry, I can't help it. So anyway, we have a scroll pointer. That pointer will get increased, and it will after a while reach this wrap point, and we need to compare against that before we plot a character. And when it wraps, we need to wrap back so that it starts from the beginning, and that's basically how to read the ANSI or ASCII characters of the text string itself. So this is a text string. So let's move on here. So what we should do is, I keep jumping to the wrong address. So there might be a point where we want to skip the plot char altogether if there is nothing to plot. So again, let's do the actual checking in the main loop. And you should, when your main loops get large, you should really take care of cleaning them up, and maybe move all the event stuff, the things that have to do with things moving on the screen, things changing and things happening, into a separate routine. And perhaps later that will become your little engine, your little demo engine that syncs stuff and makes the demo progress, because demos that progress, you have to put in a lot more work, but they are, I think, more enjoyable. Even though I must say, if I see a one screener, so-called, that is a demo that starts and it has one screen and it presents various things on that screen, maybe a single effect demo, if the stuff that I see is high quality and well programmed, I can enjoy that as hell. So I have no fetish for long multi-part demos. Rather, it's a very delicate balance to make such demos without perhaps 1 minute of the demo becoming dull as hell with a lot of messages or less lower quality effects and so on, that you're just waiting for them to end so you can see the good part. So anyway, focus, photon, focus. Focus your laser beam on the task at hand, which is to check if we need to plot the character at all. So we do it the same way as we did with the other with the counter, but we move into an address register. We compare it to scroll text wrap, and as long as it's lower than that, we don't plot. And that should be there because we don't have any special codes to make us skip the plotting of the characters when needed. But we just need to wrap the pointer onto the start. That's simple enough. As you know, there's an alias for that called like that, and that is a relative instruction, so we just save 2 bytes of code. And whether it wraps or not, we still need to move the updated pointer back to the scroll pointer, which cannot be made. There's no instruction for writing to PC relative addresses. But we also, of course, need to increase it. You can increase the scroll pointer afterwards. You can increase it in the plot char routine. You can increase it before anything happens, but of course then you need to modify the initial scroll pointer to point to scroll text -1, which is very ugly according to me. So instead we'll just say that the plot char routine must preserve A0, and afterwards we will add 1 to A0, and that's actually a valid instruction. It does affect the whole long word of the address. So let's go. And we've just created a parameter for our function. So that, and we already see that we preserve all the registers including A0, and we know that blitweight does not modify A0, so we can freely use A0 to fetch the numeric value of the ASCII character that we're fetching from the font. And the first character is J, so it should be 65 plus 9, right? So 74. Anyway. And I almost pressed F10, which ends the recording. It's so easy to hit that key, just because I have these keybinds since the 1980s. They're stuck in my finger bones. I have to watch myself. So, we put it in some data register. That's the, I'm going to say ASCII value, because rarely, very rarely do fonts use ANSI characters. Such characters could be German umlaut characters or Swedish umlaut characters. But there's a jump in numeric value between the Z character and the O with umlaut character, for example. A big jump, which you would have to take into consideration then. So well, I don't know. I'm going to call it ASCII value. Just because I'm like that. I'm going to clear the D0 word first because I'm going to divide, I'm going to subtract, since the font, let's see how we do this. I'm going to subtract what should I subtract? What the hell? I'm totally lost. This starts with A anyway, and we need to make a character table, which is the easiest way to do it. Otherwise you'd have to have a lot of compare statements in your character lookup routine. What we should get out is a number of the character in the font from the numeric ASCII value. And that means we need to make a mapping of the ASCII values to the to which character we're plotting in the font. So we will need to make a table simply. We can make this table with sort of offsets, so why not introduce that? We're going to call it CH for character because I'm lazy. So that's how much to add to the address for each character in the font, and that's how much to add for each row in the font. I'm going to keep that short because I know I'll have to use it in the table, right? I'm thinking about what's the best way to do this. I'm going to keep the constants anyway. I think I'm going to do a straight byte table from an ASCII byte to a number from 0 and upwards to however many characters we have in the font. So I'm going to declare the table here, and I'm going to move it down to the data section when done. And the way this works is that it should start at, normally you would start a font at the space character because all the values below 32 in the ASCII dimension are control codes. If you're making a writer for the screen instead of a scroll, you might want control codes such as new line or return or enter or whatever you want to call it. You might want to have tabs and so on, but not for a scroller you don't. And so we're not going to waste any space on declaring lookup values in the table for the control codes below 32 in ASCII. So where is space in this font? We need to look at the font picture to find that out. Presumably it would be last in the font, but I don't know how many characters there are. I drew in the font. So, and I can't start Deluxe Paint right now because I have 512k of, actually I have a lot of chip mem. That's an accident. I meant to show that you can do all this just with half a meg of chip and half a meg of fast. So, okay. Why not? Why the hell not? I'm going to use 8 colors at least. That's the one. Nope. So there it is. So we have 9 by 4, that's 36. 7, 8, 9, 40, 41, 42 characters, which means these are numbered. These will be numbered from 0 to 41, which is this character here. this apostrophe, and the number 42 is assigned to space then. If you'll squeeze me, I will run Notepad and write these down, the last special characters there. So after 9 we have dot, comma, exclamation mark, question mark, dash, slash, and apostrophe. Just for reference, so that I can close down Deluxe Paint. So that means that we should type 42 here. That will point to this space after the last character in the font. Then I know that exclamation mark follows, which means that we should type 37 there. This is all guesswork. We'll find out if it works, and if it doesn't, we'll just write out all the characters and change the values until all the characters are mapped correctly. If you want, you can look at the top row of your keyboard. If you have an American English keyboard, then the numeric values 33 and up matches shift 1, shift 2, shift 3, and so on. And I can only find exclamation mark there. That we can map to a character that we have drawn. So we need to make a block of zeros here. And that block should go from ASCII code 34, because we've declared 32 and 33 here. 34 up to 48, so that's 14, right? We may need to have to insert values here if there are some, I suspect, some dashes and stuff in between there. But either way, now we're at ASCII code 48, which is where the numbers start, and the numbers started at, I believe, 36 minus 9 minus 2. What's that? That's 27 minus 2 is 25. Whoops, that's too much. That's 10 of them. And then we have a space from 58 up to 65. I'm going to do that. And then the alphabet characters start. And they, of course, start at 0. So just keep this up until you hit 25. Because there are 26 characters from A to Z. And they start at 0, 0-based index. So it's so hard to do things and talk at the same time. Should have been born a girl. And I could juggle and code and talk and Twitter at the same time. So there we go. That's A through Z. And basically we're done. I'll need to declare, I may have to declare some character up here. Not sure. Don't think so. So anyway, that's the font table. I'm going to subtract 32 from the ASCII value. We're gonna put font table in an address register different from A0 so as not to overwrite the scroll pointer. Well, actually, we don't have to care about that because we restore A0 afterwards. So anyway, why not reuse that and use an effective addressing mode to look this up. And this is the reason I cleared D0, because there is no D0.b effective address mode here. And in the same fashion, just reuse D0 again, and that's the number of the character in the picture. Now, and the upper half of the word is still cleared, unless we encounter a control code below 32, because then it will become negative, but we don't use them, so we don't need to code for that occurrence or scenario. All right, so we have a word. In the lower byte, it contains the number of the character that we want to plot, and we should divide this, and we know that the high word of the long word is also cleared, so we can divide unsigned by 9 to get the row, plus the remainder in the high word. Remember, always remember that when you divide, you taint or overwrite the high word of the long word with the remainder between 0 and 8 then. So the high word now contains the number of the character on the row, and the low word contains the row, all with 0-based index. So that row 0 is the top row, and column 0 is the leftmost character. So to get this out then, to get the high word, the remainder out, we copy the whole register to another register and swap it down so that the high word becomes the low word and the low word becomes the high word, and we call that the remainder column. And this is then the row, so that now the high words in both registers are tainted, but as long as we don't use the high words of these register D0 and D1, we don't need to worry about that. So now we need to puzzle the row and column together to get an address offset into the bitmap of the font picture. And we do that by multiplying by row and let's rename that to column. Then it becomes a bit easier. So we got the row in D0, and that gets us the bitmap line that row starts on, the offset. And this multiply instruction generates a full long word, so that this full long word is now valid again. The high word that contained, so to speak, junk is now overwritten by the actual multiplication result. And we don't need, well, we need to multiply D1 by column as well, and the experienced coders among you will now tear their hair from their follicles and cry in dismay at the waste of CPU cycles. This can be done with a shift that takes a lot fewer cycles. But we will not care about that. Consider it extra course credit. Or something. I don't know. So now we just need to add them together. Put them in D0, and that's the long word offset. And now we just need to add the base to it. And this is also wasting a few bytes and cycles, but it's shorter and more understandable, so that's why I use it. So now we have the full address that points to the character in D0, and we can replace this harangue with D0, and we have our source address. So that's basically it. We can make this dynamic as well. We could make this dynamic if we really wanted to, but why waste so much time on one line of code just to make it dynamic? Maybe if you make a demo with 20 different fonts or 50 different fonts, and each in their own scrollers. And by all means do. I mean, now you know how to scroll. So why not do that? Would be cool. I remember word at odd address means we have declared bytes somewhere and we need an even statement. And by the by, we should move that down to the data section to be nice and clean. So there we go. I think, I hope. And we still haven't done the we need one after the scroll text as well, because it consists of an odd number of bytes. And let's see if we get garbage or text. Well, something. Feeling of it. Well, it's almost correct. So something is wrong with the division or the number of characters per line or something like that. More probably, though, it's a problem with the character table. So why not put in some test data? Let's see if the first characters of the font are done correctly. So now we jump down to the next line. Still correct. Could be that we skip a character and reuse O as 0 or something, but I don't think we did. So now we question our ability to count from 0 to 25. Certainly nothing wrong with that. So probably we'll need to look at the font picture again. It's always good to check your bullshit. Because after all, it was a few weeks ago since I drew the font. And where is it now? Media. Fast car font. Oh yeah. Nope. 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So far it's verified. 10, 11, 12. And so on. Oh, we haven't drawn the character N. That could be a very valid reason for the font not mapping correctly. So after a bit of housekeeping, shifting all the characters, one character to the right, and inserting, we are ready to insert the N character, and I'm gonna do a cheapo solution here. Just copy and paste. And who the hell knows where that... Okay. Cut off a bit too much of the W there. So, and we need to fix the highlight here. And we're going to pretend that's perfect already. And just save it again. And quit. And convert. Bird. Come on. And don't forget slash typing too fast for it. Redirectory, fastcore font, load. Bring the depth down. No, it's already 3. Okay. That's good. 284 by 100. You say. And that is here with verified. 284 by 100 by 3. Did I put it behind it? I think so. Save. And here's a useful tip. If you've ASM1 uses a sort of a cache to for include files, so that you should zap. Let me display that. Zap incmem like that to make sure you get the updated version of an included file. And basically that should be it. Didn't change the source, so I don't have to save it. And we got a J, and we got a problem with an apostrophe because we counted the characters and there are now one more character, so 43 instead. This may or may not need to be increased. It needs to be increased, right? 25, the number of characters came after the N. So naturally they should start after the Z at 26 and end at 35. Apart from that, it should be fine. Let's see if we have some readable text here, apart from the first few characters, just for the retro feeling of it. Oops, we have a W sticking up into the N there. And all that just because I deleted a little too much. So that's sometimes how it is with your own works of art or works of art that are delivered to you. Chop it off. I'm gonna check the alignment, and that seems fine, so that I could save it again. By the way, a good tip is to never save a picture when you have a stencil active, because, well, if that's what you want to do, then you should do that. If you want to continue to work on the picture in stencil mode, then by all means save it with stencil mode on. But for all other uses, turn stencil off before saving. For example, if you're gonna deliver the final artwork or something, such as we are doing currently, presently. Italian was a good coder. did some interesting demos. And we need to zap include mem again, and actually I'm not 100% sure that if the include mem is only for files included with the include statement, and perhaps not for files included with the incbin statement. It should be determined easily by assembling again and see if it... Yeah, it's just for source files, so what I just said, pay it no mind. So anyway, now we need to handle the special characters. So now I need to cheat and look at some ASCII table that I put somewhere on my hard disk. So bear with me for a few seconds. And we're waiting for some hard disk to spin up in true Windows style. Actually, you know what? I might as well just Google it. ASCII table. And you should too, because it's useful. ASCIIcode.com. And it has them in decimal. It has them in hexadecimal, octal, and binary. And we need, what do we need? We need to pick this. 44 is comma, 45 is dash, 46 is dot, slash is 47. Convenient. Though I do not remember, I should have the picture printed out on a blimming sheet, paper sheet lying next to me, because I don't remember in which order they came, but I know where dot is 36. So we're gonna try. So offset 44 is 4 bytes before this. So we need to subtract 4 bytes from this and then declare 4 bytes here. And we should declare 37, 38, 36, 39. And we should test that. I'm going to type comma dash dot slash. Almost correct. So the slash was a question mark, so we know the question mark now, which is 39. But we make that 40 and see if it's fixed. That's a dash, so now we know the dash. And the dash goes there. So we try 41. Is that the slash? Yes, it is. Comma dash dot slash. So that's what we got. We only have a few left now. I'm gonna replace ABCD with the ones that are left just to see what they are. So just type something here. ABCD. And do we have any left? We have declared all the ones up to 37. So we got 38, 39, and 42 left. 38, 39, 42. That's ABC. And we already declared 38, right? So 39 was what? Question mark. And 42 was apostrophe. Question mark is 63, which is 2 bytes before. And I already forgot what it was. Okay. Question mark is 39. The other is apostrophe. So 2 bytes before this, we need to declare a byte followed by a 0, and that byte should be 39, which is a question mark, and the one we have left is the apostrophe, which is ASCII code 39. So here we are at 32, 33. Then there are 1, 34, 35, 36, 37, 38. That's 5. And 1 in between, which is 42. So now we should be able to test that with a question mark and an apostrophe. And then all the characters of the font will be mapped. And it works. So now we can type just what we want. So basically that's it. That's how to make a scroller. I'll probably get back to this and maybe refine it. We will certainly move the scroller around on the screen and do something about the sprite and compose some music for our demo, and then we're done. So until then, I'm Photon, signing off. Have fun coding. Oh, I forgot. I forgot to make the eye proportional. So let's see here. That looks horrible. So the way to do this is to check some stuff. Here's where we have the compare value for when it should wrap. If the last character plotted was an I, it should wrap sooner, right? So this value should be modified. It should be dynamic. So let's put it in the data register. Oops, up here, which is initialized with the default value. You can also make, if you have a truly proportional font all the way, then you could make a font table for widths the same way we just made a font table for ASCII values that maps the widths of the characters onto the font characters. But that seemed a bit overkill for just the exception of one character. So what should happen here is if the last plotted character was an I, then it should modify this value so that it wraps sooner. Oh, and we subtract one character here, which is, well, it's pure, but you could just as well, since we're using values divisible by the scroll speed, which is 4, then we could just replace that with the clear command, clear instruction. So what to do next is the correct way is to store from the plot character routine which character it plotted last. Else you'd have to use an offset to this scroll pointer. You'd have to get an offset of -1 from this, get that character, and if it was an I, then it should wrap. Then it should wrap sooner. But we also have a wrap pointer for the scroll text and around the edges of the scroll text, especially when we read the first character, it will read from outside the scroll text, and if that happens to be an I, then undefined things will happen. Nothing bad, I'm sure, but it's conceptually correct to store the last plotted char, because then if we add control codes or such, or multi-byte codes or whatever to our scroll text, then everything will work as expected. So let's do that. We're gonna put that in a variable that we call, as soon as we read it here, last char. We're going to declare that, and that's a byte, so I want to put that before the even command. Last char. And we should declare that as 0 or something. Something that is not I anyway, unless you want, I don't know, do as you wish. It shouldn't really matter what it says there. So, okay then, capital L it is, and so that when we plot a character, then we store the last plotted real character. If it happens to be a 1, an I, sorry, then we modify this value so that we can just compare. You can use single quotes and double quotes interchangeably in as one. And we need an address register for this, so A0 is free up to this point. Well, we could just as well waste the data register if we want. D0 is free. Mobile last character, PC, comma D0, and compare that to the data register, and if it's not equal, then it's not an I, and it should not be thinner. Otherwise we should modify the character width to something like that. Let's see how that looks. So there we go. Yeah, looks good. So that's some information about proportional fonts and making an exception for a few skinny characters. Thanks for watching. See you in the next tutorial. Bye.